All right, so we're doing the rest of 2.3.2 today, higher degree polynomials. And today we're going to find the zeros of polynomials and then what is the multiplicity of those zeros. And then using those zeros to sketch a graph. Okay, so kind of a warm-up review from last time. Think about which ones of these is a polynomial and which one isn't. So one is and one isn't. Think about which one is which. Okay, if we simplify this first one, the cube root of 27 is 3, and the cube root of x cubed is x. So this one is a polynomial. If we look at this one, square root of 9 is 3, but the square root of x squared is going to be the absolute value of x, which then makes this not a polynomial. All right, so some definitions here. Zeros of polynomials are all the values that make your function 0. So exactly like they sound. So looking at this one, we want to figure out, well, what is the zeros of this? Is what makes each of those parentheses or parts of your factored out form 0. So when x is 4, x is -3, and x is +7/2 would be the zeros of this equation. A note here, zeros, roots, x-intercepts all mean the exact same thing. So I usually say zeros or roots, but they're a different word for the exact same concept. So looking at this one, we want to figure out, well, what is the zeros for this? So the first step is to factor. Well, looking at this, every single term has an x squared. So I'm going to start by factoring out an x squared. So you get x squared times 2x squared minus 3x plus 1. And then see if you can keep factoring this. We can. So again, the way I factor, you multiply those two together. So what multiplies to be 2 and adds to be -3 would be -2 and -1 over your coefficient in x. This simplifies to -1 over x. So you get x squared, don't forget to bring this down, times x minus 1 times 2x minus 1. Again, you can factor however works for you, but that's my method of factoring. And then from this, we can get the zeros. So this one gives us x equals 0. Here we get x equals 1, and this one would be x equals a half. So now we want to go backwards. So we want to write the cubic function from these zeros. So you're basically going to write out your factored form. So let's just say y equals, we'd have x plus 1 would give us the -1. So that's the opposite of what your 0 is. X plus 2, and then x minus 5. And then at this point, you're just going to factor everything or expand everything out. So x plus 1 times x plus 2, you'll get x squared plus 3x plus 2 times x minus 5. You could potentially multiply all three together at once. I'd recommend doing 2 together and then times the third one, just so you don't get mixed up with all of your expanding. So then this would become x to the cubed minus 5x plus 3x squared for the first chunk, and then minus 15x plus 2x minus 10, and then you're just combining all of your like terms. So you get x cubed minus 2x squared minus 13x minus 10. And then make sure you have a y equals. If you don't, if you just have this written out, it's an expression, it's not a function. So you need to have y equals or f of x equals or f of g equals. You need some sort of y equals to make it a function. Otherwise, you're just talking about some expression of x things and it's not answering the question. I will take points off if you don't have a y equals on the test. So when we have zeros and they occur more than once, that can happen, and that's going to be something called multiplicity. So if we're looking at this function here, we list the zeros, you get x equals -3 from the first one, x equals +1, and x equals positive 5. But there are these powers right here. So really, this first one only happened once. So it has a multiplicity of 1. If we look at the next one, well, there's two x minus 1s. Technically, you could write that out and say x plus 3 times x minus 1 times x minus 1. So this one has a multiplicity of 2. And then the x equals 5 has a multiplicity of 3. So if the question doesn't ask you to write the multiplicity, you don't have to, but you always can. It's never wrong to write down the multiplicity. So that's that one. So why does that make sense? So if we look at this one, we have 3 different zeros right there, right? But if I moved this graph up and instead it went up and then here and then up, well, now I only have 2 zeros, but I still have a cubic function. So this is not 100% right, but it's kind of like these two zeros here merge together to give you this one. So you end up with just 1 0, kind of. So it's not always going to work exactly that way, but that's the idea of like how you end up with a multiplicity of 2. A side note here, all polynomial functions are continuous. So it means there's no discontinuities, there's no like holes. You could draw the whole thing without picking up your pencil. Okay, so some true or false here. Take a second, think about this, and then we'll talk about it. All right, so the first one says if f of x is positive at x equals 2 and negative at x equals 3, then there's at least 1 0 between 2 and 3. So let's draw a picture. We have at x equals 2, or some positive value, and x equals 3, or some negative value. And so this function here is going to have to connect those two, which then means we're going to have a 0 right there. So this one is true. All right, next, here we have a similar idea. At 2x is positive, at 3x is still positive. So this is saying there are no zeros. Well, that could be true if I drew something like this that went like that. But I could draw something that went like this, and then there are zeros. So this one is false. All right, so we're going to talk about how to sketch a graph by hand. The first thing you want to do is find the zeros first, because that's the easiest thing to plot on the graph. After that, you want to think about what's the general look will look like. So plug in some other points. So if your zeros are at 1 and 2, plug in like 0 and 3 and -1 to get an idea of what's happening. And then at the end, think of end behaviors, which we talked about before. So here, our first step, this 2 should be over here. So we have a 0 at -2, +1, and +2, right? So right off the bat, I can graph those zeros. So when x is -2, we're at 0. When x is +1, we're at 0. And when x is +2, we're at 0. So those are your straight off the bat values. And then add some other ones in there. So I'm going to start at -2, -1, 0, 1, 1.5 to go in between those 2 points, 2 and 3. And then you're just plugging them in to this to get your x and your y. So at -2, we know that's 0. At 1, that's 0. And at 2, that's 0. We don't have to think about those. Then plug in -1. You'll end up getting 6. At 0, you're at 4. We're at -7/8 for that one. And 10 right there. So that's just taking like -1 and doing -1 + 2 times -1 - 1 times -1 - 2, finding your value. So then I'm going to plot these points. So at -1, you're at +6 right here. At 0 is at 4. 1.5 is -7/8. So somewhere like here-ish maybe. And at 3, you're at 10. So like up off the graph. And then I probably should do -3 to see what you're down below or up. And then you want to think about end behavior. So if we multiply out our first terms here to think about end behavior, you get x cubed. So x cubed is odd, and the coefficient in front is positive. So we're going to have some sort of something like this, where you go to positive infinity when you go to positive infinity, and negative infinity when you go to negative infinity. So if I add that into the graph, that means this has to be down here in this direction. I'm going to go up, down, and then back up. And that would be your sketch of the graph. Okay, so graphing with your calculator is not going to be that terrible. So I'll show you, just put it into y equals. And then you want to zoom out to make sure you can see everything. And then you want to calculate the zeros from that. So if I jump over here to my calculator, you can always skip this. Again, this is calculate 84 if you want a free calculator. So go to y equals, and then the one I'm going to graph is negative x to the third plus 3x squared plus 7x minus 2. So then hit graph, and you can see what it looks like. Here we're missing that top chunk. Like over here, we're missing this part right here. So I'm going to go to window and adjust that. I need my y to be bigger. So hit window, and then I'm going to change this y max right there. So let's start with, say, 20 and see if that works. If it doesn't work, that's fine. We can put something else in there. Hit enter and then go back to graph. And now I can see the top. So you probably could have done 25 to see it better, but that doesn't really matter too much. So that's finding the window. Here we went negative 10 to positive 10, negative 10 to positive 20 for our values. Now to find a 0, we want to get to this calculate up here, the little blue part. So hit second and then hit trace, and it comes with this calculate menu. So we want to figure out our zeros. So you want to use this 2 right here where it says 0. So hit 2, and then it's going to ask you here for your left bound. That means if I think the 0 is right there, I need to be on the left side. It doesn't matter if I'm like right here on the left side or right here on the left side. You just need stuff to be somewhere on the left. Hit enter, and it will draw in that little line, depending on your calculator. Now it wants the right bound. So if I think the 0 is right there, I now need to be on the right side of that. When you're at this point, be careful. If I put my mark right over here, well, now there's 2 zeros in my little interval, and your calculator won't know which one to give you. So make sure when you are on the right side, you're not including more than 2 of what you're looking for. So use your arrow keys here to arrow over to the right side and hit enter. And then sometimes you have to hit enter again. This calculator, you don't, it just tells you right away, but sometimes you need to hit enter one more time. And then this is telling us the 0 here is at negative 1.726, blah, blah, blah. So you could round to negative 1.7 or negative 1.73, 1.726, either one. And then just repeat the process to find this 0 and this 0. So second, trace, 2 for your 0. We want to arrow over to be on the left side, and then arrow over to be on the right side, and that's at negative 0.259 right there. And I do the same thing for this one. So if I go back to here, that was this question. So the window I did was x was negative 10 to 10, and y was negative 10 to 20. There's going to be lots of answers for this, so as long as your window includes everything, it's fine. The zeros, if you did all of them, you got x was negative 1.726, 0.259, and 4.467. So those were the options. And then go check on Schoology for your assignment. That's it.